per ohm per meter.
Per ohm. Per meter you can use, but usually like standard that is used is centimeter. Okay, so you will always come across questions like, practically speaking, if you look up conductivities, it's expressed in centimeter. Or Simon per centimeter. Sorry. Okay. So next we look at the factors that conductance or conductivity is mainly dependent on temperature only, but we look at different cases of, what does conductance depend on? What are the factors affecting conductance?
Miss, what is after or?
S per
Oh,
centimeter.
as in symbol for.
Yeah. Simon है ना? S for Simon.
Yeah.
Okay. So case 1, in the case of a metallic conductor, this is the regular copper wire that you're familiar with. So in this case, conductance depends on what do you think it depends on?
Length, area.
Length, area, yeah.
Temperature.
Temperature, yes. What else?
Resistance.
I mean, अगर resistance high है तो conductance will be low. Resistance is low, conductance will be high.
Density?
Density, why?
I don't know, I'm just guessing.
No. What are the primary current carriers in the case of a metallic conductor?
Oh, metal. Huh?
Primary what?
Forget about primary. What are the charge carriers or current carriers in a metallic conductor? Why does
Electrons.
Right? So what number of valence electrons? Because it depends on electrons, only the ones that are free to move will be able to flow and carry that current. So valence electrons, the inner electrons will be stuck along with the nucleus. They will take no part in this. And in general, the nature and structure of the material, how closely it is packed and other.
What about the metal atom?
What do you mean? What
like
about
the stuff, like the number of shells or the size? I don't know.
Nature and structure of material? So that comes under nature, how electropositive it is, how easily it can lose electrons. All of that ties into the size of atom. It's a combination of these three factors. Okay. So an important point about this is the passage of current does not affect the nature of the material. It does not change the composition of the material because current is flowing. Okay. So it does not change the composition of the material. Okay. So if you have a copper wire, that wire is copper only. It's not gonna react, oxidize into something else. It's not gonna get charged, discharged. Nothing's gonna happen to the number of protons. It'll remain copper wire as it is. So another type of conductors commonly used that you've come across, apart from your regular metallic conductor, would be
What?
What did you ask? Sorry.
what other type of conductors have you come across? One is your metallic conductor, your wires. What else can conduct electricity?
Alloy semiconductor.
Noise.
Metalloids.
Okay. In terms of their conductance, conductivity, would it be any difference from your metallic conductors?
It depends on the element.
The action of it, like electrons will be the charge carriers. It will still depend on the temperature.
Yeah, that'll be standard.
Yeah. Okay. What about electrolytes?
Ions in that case.
Conduct. So, conductance.
Could you go back?
Huh. Yeah. So conductance due to ions in solution, like basically electrolytes we're talking about. So this is called so this is called electronic conductance. Make a note. Because it's happening due to electrons. Isliye it's electronic. Fun fact, this is how I realized what is in general usage. There's a difference between electric versus electronic.
Oh, can you repeat?
Now, so this type of conductance is called electronic conductance because it happens due to electrons, flow of electrons. Electric is like just general electricity related. Electronic is when electrons are involved.
But even
electric is
electrons
because
are only conducting.
yeah.
The other type with this is called electrolytic. It's not electronic. This is electrolytic or ionic conductance.
No, electric versus electronic, both will be the same because दोनों में electrons are only conducting the current.
But यहाँ पे electrons, नहीं, this is ionic conductance is different. Daniel cell में, yeah, like there, okay, electrons, instead of electrons is taking place. Here we are talking about electrolytic, like any electrolyte. So suppose you have a situation where you have a beaker, इसमें you took some ionic solution, NaCl plus, I don't know, plus H2 or something like that. When I put two ends of an electrode, and then like this may or may not be my source of electricity. I may connect it to a battery and then connected to a bulb, will this bulb glow? Yes or no?
Yeah,
Why? How will it glow?
because the Na and Cl would dissociate into ions, and they would carry the conduct the electricity.
They are the ones carrying electricity. It's not electrons in this case. In this case, it's the ions carrying electricity. So that's what
Yeah.
is electronic or ionic conductance. Okay. So again, same treatment. What does this depend on? The first one, we can say it depends on the nature of electrolyte. Strong electrolytes, weak electrolytes. Are they electrolytes or non-electrolytes? Like if you put sugar water there, is that going to conduct?
No, sugar water doesn't dissociate.
Yeah. So first one is it depends on the nature of electrolyte. The second one, it also depends on the mobility of the ions, which in turn comes from the size and solvation of the ions. So smaller ions are more mobile, they flow easily than larger ions. Solvation also relates to that, like um, how much of it has dissolved, what is the hydration level, all of that. Size and solvation kind of relates to the mobility. Mobility is literal flow. How easily can it flow? Three, it depends on the nature and viscosity of the solvent. This is something we have not like discussed this because solvent has always been water, but in general. So viscosity
What
of
you wrote about electrolytes, that is B, or
what?
what you wrote about electrolytes conductance, that is, where is that? Can you go back? Sorry.
Oh, different types of conductors we're seeing. Like first being metallic conductors. Second is electrolytic conductors. Conductance due to electrons in the metal, conductance due to ions solutions. So the viscosity is again like this will control the speed of the ions. How easily can it flow? If you have like a really viscous, this is something you can imagine practically. If you have a really viscous, something like honey or oil, difficult to move within that compared to something that's pretty light like water. We can easily move in that.
Can you repeat what solvation means?
Solvation relates to the dissociation of the ions and how the hydration. Like if you remember solvation energy, it depends on lattice enthalpy and hydration enthalpy. So if the ions are dissociating well, if you have like 90, like 80-90% dissociation, you'll have a lot of ions available for that movement. But if it's not dissolving well, like if the dissociation is low, then low solvation. Okay. What else do we have? Also depends on the concentration of the electrolyte. Again, this ties in with the number of ions available for this thing. So you might have a strong electrolyte, but if you have like only a tiny amount, then that's not going to work. Weak electrolyte, like this is where we get into, infinite dilution case. And this is the major thing. It's going to form this particular section of the chapter, how concentration of the electrolyte will affect the conductance. There's going to be relations with this, looking at graphs and all that. And number 5, the standard, of course, temperature. An important factor to consider in this situation is that the passage of current. So the passage of current changes the composition of the electrolyte. Do you know why? What happens? Like, how does it change?
Because current is due to the ions, right?
Yeah.
So the concentration would. Oh, the composition. Yeah, because new ones are being formed, right? You'll get NaOH, right? From the
Yeah.
ion.
Yeah. So due to chemical reaction that's what electrolysis literally is. You pass current and then, yeah, thing changes. So due to the chemical reaction. Okay. Why? Like, why do we care about the composition changing over time? Like, as you keep passing, as the current passes through it. So this is the reason, because it changes, like because the composition changes with time, you cannot use a Wheatstone bridge to measure the resistance of electrolytes or conductance of electrolytes. You guys have studied about Wheatstone bridge, right? Electricity to pura ho gaya na? Yeah. What do you use a Wheatstone bridge for?
To measure unknown resistance.
To measure an unknown resistance. So in this case, like if it's a metallic, if it's a wire that you're measuring the resistance of, it's like a solid thing, you can simply put it in the Wheatstone bridge and then calculate it. But you can't use that same method with the with an electrolyte, because composition changes. Matlab, like the electrolyte is changing, the ions available are changing, all of these things change. You won't get a proper value in that process.
Miss, can we stop now?
6 o'clock. Okay. Cool. The rest of it is like the conductivity cell and measurement of conductance. Then we'll have to like stop the session, or we'll do more questions on Nernst equation only. Let's see, we'll do like 3-4 questions. Farafat, like if everybody's doing it right, if everybody's getting everything, then yeah, we'll leave you guys to it. Otherwise, we'll continue to solve till you guys get that level of confidence and accuracy.
On Flipper?
Yeah. Correct.